Welcome everyone to Aditya's Creation. This is my first video. In this video, I have selected some important questions on limits which came in JEE Mains Jan attempt 2024, as you can see written on the screen. These questions will help you in understanding the chapter better, and also you will be able to differentiate between what is actually coming in the mains exam and what you are practicing. Make sure that you are sitting with pen and paper and solving the questions along with me. Please do let me know if you're facing any problem anywhere in the comment box so that I can deliver better content from next time around. And with a lot of positive energy, let's begin. This is the first question that we have on our list, and it is from definite integral as the limit of a sum. Now, I'm writing the question here, limit n tending to infinity sigma k equals 1 to n. In the numerator there is n cube, and in the denominator n square plus k square into n square plus 3k square. So before moving on with the further steps, what we need to do is just simplify this expression given here. So I'm again writing it, limit n tending to infinity sigma k equals 1 to n, 1 by, I'm dividing both the numerator and the denominator by n cube. So in the numerator it is going to be 1, and in the denominator I'm writing here n cube and taking n to the power n square from each bracket common. So it is going to be n square from this bracket common, 1 plus k square by n square into 1 plus 3k square by n square into n square from here. And therefore, as a whole, in the denominator, outside of the bracket, n, only n will remain. Right. So now I will be telling you about some substitutions that we must do to solve the question in an easy and concise manner. First of all, we must replace this sigma as, let me change the pen color. Just a second. Yeah. Sigma as integral sign 1 by n, limit n tending to infinity 1 by n as dx, and k by n as x. Right. Now if we just substitute them in this particular expression, then we can write it as, first of all I'm writing dx, limit n tending to infinity 1 by n as dx, sigma as integral sign, and 1 plus k by n as 1 by k by n, k square by n square as 1 plus x square into 1 plus 3x square. Sorry. Now we need to find the limits of x. In order to find that, we must understand that k is ranging from 0 to, sorry, not 0, it is ranging from 1 to n. Here you can see k equals 1 to n, right? And if we divide this by n on all the sides of this inequality, then it is going to be like this. And n is something which is tending to infinity, that is positive infinity. Therefore 1 by infinity we know it is going to be 0. K by n we can write it as x, and it is 1. So the values of x lies from 0 to 1. Now we just need to solve this integral right here for getting our required answer. Now here you can see there are two factors in which x has quadratic power. So what we can do is we can write this numerator as the sum or difference of these two factors. 1 plus x square 3 times minus 1 plus 3x square and 1 plus x square into 1 plus 3x square. Okay, so in the numerator you can see that if we solve this, 2 will be remaining in the numerator, and therefore we need to adjust it with 1 by 2, and we need to put this dx and the integral sign right here where the limit of x is from 0 to 1. Now if we just break this integral into two parts, in the first part it will be 3 by 1 plus 3x square dx, and in the next part half integral 0 to 1 1 by 1 plus x square dx, right? So it is this integral, whatever this and this both are of the form like 1 by a square plus x square dx, whose integral we know is 1 by a into tan inverse of x by a, right? Right, we know this. So using this, we what we can do, 1 by a, here a you can see is 1 tan inverse of x, here x is basically root 3x. Okay, root 3x by a is basically 1 here again, and putting on the limits 0 to 1. Again, in the next part, what we can write here, it is simply 1 by a is 1 tan inverse of x by a, and that is 0 to 1. 3 by 2 tan inverse root 3. Tan inverse root 3 is basically pi by 3, and that is 0. Tan inverse of 0 is 0. So, like this, I can write half into tan inverse of 1, that is pi by 4, right? Now I think I made a mistake here. Tan inverse of root 3x, we need to divide this also by root 3, as x has the coefficient root 3. So wait a second. We need to divide this by root 3, right? So this is very important. If we do that, not only here, it will be better if I write it right here. So ultimately it is going to be pi by 2 root 3 minus pi by 8, and if we take pi by 2 from here common, 1 by root 3 minus 1 by 4 is going to come here. Pi by 2, 4 minus root 3 by 4 root 3. Now let us check the answers. So we need to rationalize basically. So let's do it. Pi by 8 root 3 into 4 fours, if we multiply the numerator and denominator by 4 plus root 3, then it is going to come like this: 4 plus root 3, 13 pi by 8 root 3 into 4 plus root 3, like this: 13 pi by 8 into 4 root 3 plus 3. So the required answer here is number 4. So this is our next question, and in this particular question we need to find both the left hand limit and the right hand limit of fx at x equals to 0. So I am going to first find the left hand limit, and therefore I have written it like this. Now if we carefully look at this expression, we are going to find that The main problem causing part is the fractional part of x function. Now, according to our definition of fractional part of x, we can write this as x minus box of x. Now, x, if we put x as 0 minus delta or minus delta even, and we can write x as minus delta, and since delta is tends to 0 from the positive side, therefore minus delta is something which is less than 0 but very close to 0, and therefore the nearest integer which is close to minus delta and that is less than or equals to minus delta is minus of 1. Therefore fractional part of x when x tending to 0 minus delta is 1 minus delta. Therefore we can substitute fractional part of x in this particular limit as 1 minus delta. Now limit x tending to, we can, we will not be writing limit of x, we will be substituting x as 1 minus delta. Therefore we are going to write the limit of delta tending to 0 cos inverse 1 minus delta the whole square into sine inverse 1 minus 1 plus delta. Here we can take 1 minus delta as common and 1 minus delta the whole square. Now since delta is tending to 0, now if we put delta here, we will be finding that cos inverse of 0 right here, and that cos inverse of 0 is basically your pi by 2, right? Sine inverse of 0, that is 0, and in the denominator it is going to be 1 into 0. Now there are two parts in this. Now we can break this expression into two parts: the part in which 0 by 0 form will be there and the part in which we will not be getting 0 by 0 form. So we are going to just do it. We will be separating this limit and put delta as 0 in the parts where 0 by 0 form is not going to be there. So this cos inverse, this is going to be pi by 2 and 1 in the denominator. Now limit delta tending to 0 sine inverse delta by 2 delta minus delta square. We can do another step right over here. 2 minus delta into delta, right? Now sine inverse of delta by delta 0 by 0 form, it is going to be 1, and 2 minus delta, if we put delta as 0, it is going to be 2 in the denominator. So as a whole it is going to be pi by 4. L is equals to pi by 4. Now if we look at the right hand limit part, right, what are we going to get? Limit delta tending to 0, sorry, limit x tending to 0 plus delta, the same as here, that is cos inverse 1 minus fractional part of x the whole square into sine inverse 1 minus fractional part of x divided by fractional part of x minus fractional part of x the whole cube. Now if we analyze fractional part of x over here by using the same definition, that is x minus box of x, and put x as 0 plus delta, here x is going to be delta, but x minus box of x and delta tending to 0 from the positive side of the number line, then it will have the nearest integer which is less than or is equals to delta is going to be 0. So it is going to come as only delta, right? Now similarly in the next step we will be writing limit delta tending to 0 cos inverse 1 minus delta square, delta का square into sin inverse 1 minus delta divided by delta minus delta q. We can do delta, we can take delta as common and 1 minus delta square. Okay. Now you can see if we put delta as 0 in the expression above, in the expression, cos inverse of 1 which is basically 0, sine inverse of 1 which is basically pi by 2, in the denominator it is delta as 0 and 1. Again similarly we will be separating this limit into two parts, one having the 0 by 0 form and another not having the 0 by 0 form. The part having the 0 by 0 not having the 0 by 0 form, we will be just putting delta as 0 in them, like sine inverse of 1 minus delta and divided by 1 minus delta square, it is basically going to be pi by, it is basically going to be pi by 2, right? Into limit delta tending to 0 cos inverse 1 minus delta square divided by delta. Now what we can do from here is we can use L hospital rule rather than using expansion of cos inverse of 1 minus delta square, something like that. I think it's better. So limit delta tending to 0 1 by minus of 1 by root over of 1 minus 1 minus delta square the whole square into minus of 2 times delta, and we had delta in the denominator whose derivative is going to come as 1. In the next step we can write, in the next step we can write pi by 2 into limit delta tending to 0. In the numerator there will be 2 delta divided by square root of delta square into 2 minus delta square. After simplifying this, now square root of delta square is basically delta, and this delta square, square root of delta square and delta is going to be cut off, and this 2 and this 2 is going to be cut off, and if we place delta as 0 in the denominator, therefore it is going to come as pi by root 2, right? Now we are required to find 32 by pi square left hand limit square plus right hand limit square. So we know that left hand limit is basically pi by 4, that is pi square by 16 plus pi square by 2, right hand limit pi by root 2 we have found out. Therefore it is going to come as 9 pi square by 16, and this pi square and pi square is going to be cancelled out, therefore it is going to be 18, right? Up next we have this particular question, and in this particular question I have written it here. You can see the main problematic part is mod of sin x. Now whenever we have functions like mod of sin x, mod of, that is basically mod of x, box bracket of x, fractional part of x, square root of x, we need to break the limit into two parts, that is left hand limit and right hand limit, to check whether the limit exists or not. Okay, and to add to this, uh, confirming, to add to this, we have an option that is doesn't exist, so we must do that. Okay, so in order to find, I am going to first find the left hand limit, and To make this limit as left hand limit, we are just going to do this alteration here. And if we place limit x tending to 0 minus delta, as here it is going to come limit delta tending to 0 e to the power minus 2 sine delta. Since sine of 0 minus delta is sine of minus delta, and sine of minus delta is basically minus of sine delta, and delta is something which is very much close to 0, and hence sine delta is positive, and on multiplying with minus 1 it is coming as minus. Therefore the mod will open with a negative sign, and here also it is going to come as 2 sine delta minus 1 divided by delta square. Delta square. Now, in the denominator, it is coming as 0, and in the numerator also, e to the power 0, that is 1 minus 1, and this is also 0, so it is again 0. Okay, so it is 0 by 0 form, and we are going to use L hospital rule right here. Limit delta tending to 0, 2 times delta e to the power of minus of 2 sine delta into minus of 2 cos delta plus 2 cos delta. Now we can cut this 2 off right here. Okay, we are going to take cos delta as common, cos delta by delta as common, and 1 minus e to the power of minus of 2 sine delta. Limit delta tending to 0. Now if we can separate the limit here also, that is the part in which 0 by 0 form is there and the part in which 0 by 0 form is not there. So cos delta by, we can put 1 here, and in the other part there will be 0 by 0 form. So I'm directly dividing both the numerator and the denominator. So then it will be e to the power of minus of 2 sine delta into minus of 2 cos delta divided by 1, and putting limit delta tending to 0. Therefore, it is going to come 2 into e to the power of sine 0 is 1, sine 0 is 0, and e to the power 0 is 1, and cos 0 is again 1. So the answer of left hand limit is going to come as 2. Right, we are having an option 2, so let us check the right hand limit also. These two options are eliminated. So limit x tending to 0 plus delta. If you can do this question before me, do write it in the comment box and check your answer also after I'm finished solving. So e to the power sin x minus 2 times mod of sin x minus 1 divided by x square. Limit x tends to 0 plus delta. If we put x as 0 plus delta right here, then we have to write limit delta tends to 0, as the variable is now delta. Now sine of 0 plus delta is sine delta, and the inside this mod it is positive, therefore it is going to be opened with a positive sign. So e to the power of 2 sine x minus 2 sine x minus 1 by, sorry, it is not going to be x, it is going to be delta. Sorry, let me just, to the power of 2 sine delta by minus 2 sine delta minus 1. Now, if you see here in the denominator it is 0, and in the numerator e to the power of 2 into 0, that is 0, 1 minus 1 0, and it is also 0. Therefore, again, see 0 by 0 form, L hospital rule, apply it, get the answer. E to the power of 2 sine delta into 2 cos delta minus 2 cos delta 0, limit delta tending to 0. See, you can cancel out 2 and also take out cos delta as common. E to the power of 2 sine delta minus 1 by delta, limit delta tending to 0. If you put cos delta as 0 here, and you have to separate this limit into two parts, one in which again L hospital rule is valid, and another part in which the L hospital rule is not valid. So cos delta we will be putting it as 1 into, again, e to the power of 2 sine delta into 2 cos delta 0, derivative of minus 1, and delta 1. So if you put delta as 0 here, cos 0 is 1, and e to the power of 2 into 0 is again 1. So we are having the right hand limit and the left hand limit equal, therefore the limit exists, and hence it is equals to 2. It is not this also. Okay, so up next we have this question, and in this particular question we can do it in two ways: by using L hospital entirely, or by using first expansion of the functions e to the power x log of 1 plus x and sine of x. It is optional. uh, and or we and I am going to do the question in the second way actually. So let's start. Limit x tends to 0, a x square, the expansion of e to the power x is 1 plus x square by 2 factorial, and so on, minus b into log of 1 plus x, it's basically x minus x square by 2 plus x cube by 3, so on, plus c into x into just 1 minus x plus x square by 2 factorial minus x cube by 3 factorial, and so on, right? In the denominator, what I am going to do is I'm going to expand this, and it is basically x minus x cube by 3 factorial plus x to the power 5 by 5 factorial, like this, so on. So if you look here carefully, if I use L hospital right now, before using L hospital we can do one thing, that is, in the denominator and in the numerator we can divide by x, as here in all the three terms x is present as a common factor. So like this we can do, we have to just do a bit of wait, wait. Okay, and from here on it is simply this. Okay, now if we do L hospital it will be better. Now we can also move this x inside and then solve. That will be again a better thing to happen. X square, x cube, and so on. Therefore, in the next step, 1 plus 2x plus 3x square by 2 factorial. In the previous step, I forgot to tell you something that if we place x0 in the numerator and denominator, for the numerator to become 0, minus of b mass plus c must be equals to 0, so that there is 0 by 0 form and L hospital is applicable. So like this. Therefore, minus of 1 by 2 plus 2x by 3, like this, plus c into minus 1 plus 2x by 2 factorial minus 3x square by 3 factorial. Correct. Now in the denominator what we can do is, okay, I'm moving this x inside and applying 4x cube by, and dividing matlab, applying L hospital, 6x to the power 5 by 5 factorial, so on. Now if we again put x as 0 in the numerator and denominator, for the numerator and denominator to be 0 we have to understand that like this. So a is equals to basically c by 2 if we put b as c, or 2a is equals to c equals to b. That is also very well possible. Okay, now in the next step, limit x tending to 0, a and b, and if we again apply L hospital, a into 2 plus 3 into 2x by 2 minus b into 2 by 3 plus c into 1 minus 2x by 2 by 2 minus 3 is at 12x square by 3 factorial, and we don't need to think about the rest of the terms, whatever is there. Okay, so right now we know this limit is basically equals to 1 as given in the question, you can see here. Okay, so if we again place x as 0 for the, and the denominator right now is 2, and the numerator, right, in this particular case is 2a minus 2b by 3 plus c is basically equals to 1. So 2a minus 2b by 3 plus c is equals to 2, and therefore 2a we know it is equals to c. So 2c and b is also equals to c. So 2c minus 3 is equals to 2. So c minus c by 3 is basically 2c by 3, and which is equals to 1. Therefore c is equals to 3 by 2. C is equals to 3 by 2. B is also equals to 3 by 2. And A, which is equals to 2A, is equals to C. Therefore A is equals to 3 by 4. Okay. A is basically equals to 3 by 4. Now, if we if we put the values of A, B, and C in this particular expression, then it is going to come 16. The value of A is basically 3 by 4. Therefore 9 by 16 plus 9, B and C both are 3 by 3 by 2 each. Therefore 9 by 4 into 2, that is 9 by 2, and when it is being multiplied with 16 we will be getting 9, and 9 by 2 into 16, that is 9 into 8, 72. Therefore the net answer is going to come as 81.